Hope you're ready for an epic battle, because we're going to be talking about arguably the most important virus, and that's human immunodeficiency virus, or HIV. This beast of a virus has a lot of information, and I mentioned epic battle because that's exactly what our scene's going to be. Welcome to the battle against the evil wizard, who has at his side the most powerful immunosuppression cane of all. One cane to rule them all. So just a little backstory as we're drawing out the scene. A century-long battle has raged between the town squires and the evil wizard. The squires were seemingly triumphant, banishing the wizard to prison for what they thought was once and for all. But the wizard wouldn't just give up so quickly. So now this scene is the escape of the wizard from prison, and the battle that ensues during this attempted escape. So let's draw our wizard here, who will represent HIV. Notice the big wizard's staff in his hand. It's the ultimate cane, right? Like the name suggests, human immunodeficiency virus will lead to AIDS, acquired immunodeficiency syndrome, which is the quintessential state of being immunocompromised. HIV is a retrovirus, which is a single-stranded RNA-positive virus that gets converted to a DNA intermediate by an accompanying enzyme, reverse transcriptase. Once it becomes DNA, it can get incorporated into the host chromosomes and replicate forever. So despite this extra step, it's still technically a positive sense RNA virus. So take note of the positive sense sun in the background. Also, notice the orange warm hues to remind you that HIV is an RNA virus. Alright, let's talk about some more characteristics of the virus, which will be illustrated with our evil wizard. First, notice that he's wearing a large white robe, which represents that the virus is enveloped. We'll also draw on a unique hat, a wizard's cap, that has two orange dragons on it. The two orange dragons are supposed to represent the diploid nature of the virus. There are two molecules of positive stranded RNA in each virion. That's why there are two dragons that are orange for RNA. Now when we talk about HIV, there are three very important genes that the virus uses for replication. They're called the ENV, GAG, and POL genes. Each of these has its own purpose, and we're going to illustrate all of them on our wizard. In fact, we've already started to illustrate the GAG gene with the wizard's hat. GAG is a gene that makes the protein P24, which serves as a capsule for the RNA strands. And just like a wizard's hat is cone-shaped, so is the P24 capsule. It actually really does look a lot like a wizard's hat. To help you remember the number 24, we're going to draw on the brim as a sundial. The sundial measures time, and there's 24 hours in a day for P24. The next gene, ENV, is short for envelope, is responsible for making the glycoproteins 41 and 120, which are proteins that serve to form a viral envelope. In fact, ENV makes glycoprotein 160, which then gets cleaved into glycoprotein 41 and 120. If you take out the ones, you're left with 420. In the US, 420 is the unofficial holiday of marijuana smokers, so we thought it'd be fitting to put this on a pipe. I mean, all wizards need pipes, right? Since this is associated with the ENV protein, we'll have some of the pipes sticking out of his robe, too. So GP41 is the transmembrane protein in the envelope. So we have 41 on the stem of the pipe, the part that goes into his mouth. It's also on the end that sticks in his coat pocket. GP120 is the outer glycoprotein that will eventually come into contact with the host receptors. So we've made the 120 portion of the pipe, the bowl, the part that's sticking out away from the wizard. Remember, reading 420 from left to right, you'll remember that 41 was a part in his mouth, and 120 was the part that was away from him. The last gene I'll mention is POL, which is short for polymerase. But remember, retroviruses don't have a simple polymerase. They have a reverse transcriptase in order to convert RNA to DNA. So we're going to give our wizard a spell book titled Reverso Transcriptum. This enables him to do all of his evil spells, creating DNA from RNA. You have to admit that's pretty magical. So we have POL for polymerase, meaning the reverse transcriptum, ENV for envelope, so we have the 420 pipe sticking out of his envelope or robe, And finally, we have GAG, which is the one left over, and it's the capsule for the RNA strands, which is symbolized by his hat's sundial for 24 hours in a day for P24. Alright, let's start to fill out the rest of the picture now. Let's talk about transmission of the disease. As you know, transmission is primarily through sexual contact, vertical transmission, or through blood, whether that be through IV drug use or needle sticks. Most of these are pretty obvious, but we wanted to remind you that HIV is considered a torch infection as well. So we'll draw in some torches in the hallway. Alright, moving on. I had mentioned before that the wizard had busted out of jail. Jail. Have we used a jail in our previous videos before? That's right, Mycobacterium. You'll remember the jail, or cages, were a symbol of macrophages. And the squire helper here represented helper T cells. We're using these symbols specifically because HIV targets macrophages and helper T cells. So let's talk a little bit about progression of the virus. First, take a look at our viral wizard and notice how he's casting a spell from his staff. As we follow the trail to the left, we can follow the progression of the disease. The first squire is kneeling down and crying out in pain and grabbing the back of his neck. That's supposed to represent the primary infection, or the prodrome. It's characterized by a flu, or mono-like symptoms, with cervical lymphadenopathy. We have him with his mouth open because his tonsils may have become enlarged, and the frills around his neck and waist will represent the lymphadenopathy. He's also red-faced and sweaty to illustrate the fever. This primary infection can last for several weeks, but will eventually get better on its own. Remember that our helper squires are dressed in white because they're white blood cells, and they have the 4-shaped belt buckles and 4 feathers in their cap for CD4 positive. The virus will then enter a clinical latent period, which can last up to 10 years. This is when the virus is replicating in the lymph nodes. Since this is a latent period, we have illustrated the next squire to be sleeping. So what happens after 10 years? Well, this is when there's a steep drop in the CD4 count, and as soon as the CD4 count goes below 200, the disease has progressed to AIDS. Moving past this sleeping guy, the powerful wizard has created a rift in the earth, causing a steep drop-off into a pit with a bunch of squires falling down. There's even a sign here that says, "Watch your step, 200-foot drop," to remind you of the 200 count barrier that differentiates AIDS from HIV. But be careful, AIDS can also be diagnosed even if the CD4 counts are above 200 and there's an AIDS-defining illness present. We aren't going to go into the AIDS-defining illnesses in this video because we've definitely mentioned them in our other videos. However, there is one AIDS-defining illness that is caused directly by HIV, and we'll cover it here. HIV can cause a B-cell lymphoma, and most often, more specifically, it causes a diffuse large B-cell lymphoma. To illustrate this predisposition to cancer, we'll have the wizard conjure up an evil minion, a giant fighting crab. He's slowly marching his way up the hill, where we have a little stronghold of archers trying to take him down. Remember that the archers were our symbol for B cells, as they shoot antibody-like arrows. The archers are aggregating into a stronghold, like B cells aggregate into a lymphoma. Additionally, the crab is a very large crab to clue you into diffuse large B-cell lymphoma. Alright, let's take a step back and talk about how HIV infects its host. In order to enter the macrophages and T cells, there must be fusion of the virus with the host cell via receptors on the host cells, specifically the CCR5 and CXCR4 coreceptors. Once the virus binds these receptors, the virus enters, uncoats, undergoes reverse transcriptase, gets incorporated into the host DNA, and can make new virions using the host machinery. So to remember which receptors on the CD4 positive T cells that the virus uses, we're going to add in these banners on the backs of the squires with either this fancy CCR5 or CXCR4 logo on them. See this CCR Roman numeral 5? Notice also how the CCR5 squires are closer to the wizard. This is because in the early stages of HIV infection, the virus uses CCR5 for viral entry, and in later stages, it uses CXCR4. Alright, on to diagnosis and treatment. To test for HIV, a screening test must be done first, and this is done with an ELISA test. The ELISA is looking for antibodies. So, if tested for too early, it may come out to be a false negative, which is why multiple screening tests should be done at different time points out to 6 months after possible exposure. We'll illustrate the ELISA test with this she-elf holding an ELISA shield. The shield has arrows sticking out of it that represents antibodies. A positive ELISA calls for a confirmation test with a Western blot. A Western blot is carried out on gel electrophoresis, so check out this tapestry. Its patterning is meant to look like an actual Western blot. Remember that the ELISA elf is standing in front of and guarding the Western blot tapestry, and you'll remember to screen first with ELISA and then follow up with a Western blot. Once someone is diagnosed with HIV, it's important to measure viral load and CD4 count using PCR. Another small note about testing is that if you're worried about vertical transmission from an HIV-positive mother to a neonate, if you perform either a Western blot or an ELISA on the baby, it'll undoubtedly come back positive. Remember, the mother passes down her antibodies to give the neonate passive immunity while the infant begins to generate their own antibodies. The mother will have anti-HIV antibodies that she'll pass down, causing both the Western blot and the ELISA to be positive. So the way you test a neonate is with HIV RNA and HIV DNA nucleic acid amplification tests, and this looks for the virus itself and not the antibodies. Lastly, I'd like to touch on treatment. I'm sure by now everyone's familiar with antiretroviral therapy, or HAART, which stands for Highly Active Antiretroviral Therapy. Besides knowing the different drug classes, just on a higher level, remember that combination therapy is always better than monotherapy, especially since this cunning viral wizard is prone to mutation and developing resistance. So we're going to illustrate some of our major drug classes here in the back, but we won't go into too much detail about these drugs, as that's more appropriate for a pharmacology lecture. First, I'd like to draw the backbone of any HAART therapy, which are the NRTIs, which stands for nucleotide or nucleoside reverse transcriptase inhibitors. We'll illustrate this with this pregnant she-elf swinging this oddly shaped flail around. The flail is shaped the way it is to remind you of the structure of a nucleotide. What these NRTIs do are they pose as a nucleotide, get incorporated into the DNA by the reverse transcriptase, and then halt further elongation. So if you think of the chain of the flail being a normal viral DNA, and the end of it is the NRTI, the spiky nucleotide that inserts itself and halts prolongation. But why is she pregnant? And what does the Z on her chest stand for? Well, the Z stands for ziduvudine, the first antiretroviral approved for use, and it's the best drug to use during pregnancy, during labor, and also postpartum to reduce the transmission of the virus to the baby. It's been shown to reduce the risk of transmission by 2/3. So mothers can start taking the drug at 14 weeks of gestation and take it all the way through 6 weeks postpartum. The next drug class are the NNRTIs, or non-nucleotide reverse transcriptase inhibitors, which we'll illustrate by this he-elf holding a mace without a chain. It's a slightly different shape than the flail and has a slightly different mechanism of action from the NRTIs. It doesn't incorporate itself into the chain like the NRTIs do, but it still has the same end result of inhibiting reverse transcriptase. Overall, to emphasize that these two warriors are anti-reverso transcriptome wizardry, or inhibitors of reverse transcriptase, we'll put both of them on one of the evil wizard's magic reverso transcriptome books. The next drug class are the protease inhibitors, illustrated by this squire in the back trying to pull the sword from the stone. His name is not Arthur, and since he can't pull the sword out, he can't cut things with it, which is exactly the function of a protease, to cleave proteins necessary for viral replication. So this meat-cutting sword, or protease, is inhibited to remind you of protease inhibitors. The last class we'll mention is maraviroc, or the CCR5 inhibitor. Remember, if CCR5 is the receptor HIV uses to enter cells in the early stages of disease, if it's blocked, the virus can't fuse with the host cells. So Maraviroc will be illustrated by a mare who's rearing up on her hind legs here in the back. See how she's about to crush the squire with the CCR5 banner? Thus, she's a CCR5 blocker, or crusher if you will. That's all we're going to say about the treatment for HIV for now. Remember, we'll go into much more detail later in Sketchy Farm. So just know the general classes and their functions for now. Also, remember there are several different HIV strains out there, so you need to do genotype testing to figure out what combination of therapies is best for them. So, in general though, who should get treatment? Well, the new recommendation is that everyone should get treatment to prevent high viral loads and low CD4 counts. This recommendation is strongest for those with CD4 counts under 350, pregnant women, and those with a high viral load. Alright, that's all we're going to talk about for HIV. We've covered all the high yield points, and we only had to sacrifice 6 or 7 squires, so not too bad. So this is all high yield stuff. So I'd watch it again, and again,
and again, and again, and again. Ha 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 ha.